Welcome to the deep dive. You clicked on this, and I bet, like us, you've had that. That slightly strange, maybe even eerie feeling of being conscious, of being a subject.
Yeah, that fundamental mystery of what is this thing looking out at the world? It's pretty mind-bending when you stop and think about it.
Exactly. So today, we're diving deep into the source material on consciousness. What is it? How does it even happen? And, why?
Right. Those are the big questions. The descriptive what, the explanatory how, and the functional why. We're pulling from philosophy, neuroscience,
Yeah.
trying to get a handle on it.
Okay, but first things first. We need a definition, right? Otherwise, we'll just talk past each other. We're going with Thomas Nagel's idea here.
Yes, Nagel's famous line. For an organism to be conscious, there is something it is like to be that organism.
Something it is like.
Exactly. Think about it. A rock. There's nothing it's like to be a rock, right? But for you or a dog, maybe even, well, we'll get into insects later, there's a subjective feel to existence, an inner quality.
So we're zeroing in on phenomenal consciousness, the raw experience itself.
Precisely. And this is really important for the science. We're deliberately setting aside things like high intelligence or language, or even knowing you're self-aware. Those often get bundled in, but they confuse the core issue.
So just the feeling, what it's likeness.
Just that raw feel, sometimes called qualia, the redness of red, the sharpness of pain, that kind of thing.
Yeah.
That's the target.
Got it. Now let's hit that first big conceptual wall, David Chalmers and the hard problem.
Ah, yes, the hard problem.
Which is basically why. Why should all this physical stuff, neurons firing, chemicals flowing, why should that give rise to this rich inner world at all, it seems?
Well, Chalmers said, objectively unreasonable.
It does seem unreasonable, objectively speaking. Why aren't we just incredibly complex biological machines, processing information, reacting to stimuli, but with nobody home, no subjective experience? That's the puzzle.
It feels like a massive leap from circuits to subjectivity.
It does. And while the hard problem is philosophically fascinating, a lot of neuroscientists today, well, they find it maybe less useful for day-to-day research. 2, abstract. Not testable enough.
Kind of. They tend to focus on what some call the real problem instead.
Okay, the real problem, what's the difference?
The real problem is more about correlation and specifics. It asks, how do specific brain activities, specific neural mechanisms, connect to the specific qualities of our experience? Not just why experience exists, but why this experience feels like this.
Can you give an example?
Sure. Think about seeing something.
Yeah.
Your visual experience has a definite spatial character, right? Things are arranged in space, you can track movement. But now think about feeling fear.
Okay. Fear doesn't feel spatial.
Exactly. It has what philosophers call valence. It feels intrinsically bad. So the real problem asks, what specific neural patterns in the visual cortex create that sense of 3D space? And what specific patterns in, say, the amygdala or limbic system create that feeling of badness? It's about linking the mechanism to the quality.
That feels much more concrete, like something you could actually design and experiment around.
Precisely. It shifts the focus to mapping the brain's structure and function onto the structure and properties of experience itself.
And this is where we see those big metaphysical divides, isn't it? Like physicalism versus dualism.
Absolutely. On one side, you have physicalists, like John Searle, for instance. Their view is that consciousness is fundamentally a biological phenomenon.
Like digestion or growth.
Sort of, yeah. It's entirely caused by brain processes, and it's realized in brain structures. It's physical through and through. The unusual part, for Searle, is its ontology, its way of existing. It's known subjectively, from the first-person perspective.
So it's physical, but it feels private.
That's the idea.
Oh.
It's just a feature of certain complex biological systems, no magic needed.
But then there's dualism.
Right, the view that mind and body, the mental and the physical, are fundamentally different kinds of things, separate realms.
Which taps into that feeling most of us have, that sort of intuitive dualism, that I am somehow separate from my physical body.
It really does. It feels very natural. But some of the sources we looked at raise a really interesting point here.
Which is?
Is that strong intuition actually reflecting reality? Or is it maybe a kind of psychological bias, baked into how our brains model ourselves in the world?
Huh. So our feeling of being separate might just be a useful illusion or a side effect of our cognition.
It's a possibility raised in the literature, yes. That this intuitive sense might sometimes get in the way of understanding the actual deeply integrated mind-body connection. Something to keep in mind.
Okay, so whether it's one substance or two, we still need to figure out how the brain generates experience. This brings us to a really central idea in modern neuroscience: the brain as a prediction machine.
Yes, this is absolutely key. The old idea was the brain as a passive receiver of information from the senses, but that's really been turned on its head.
So it's not just sitting there waiting for input.
Not at all. It's constantly active, constantly generating hypotheses, making predictions about what sensory input it expects to receive next, based on past experience and internal models. Its fundamental goal seems to be minimizing surprise or prediction error.
So perception. It's not just reading the world.
No, perception is viewed now as an active construction, a kind of controlled hallucination, as some neuroscientists put it.
Whoa, okay. Controlled hallucination. Explain that.
Well, the raw data coming from your senses, light hitting your retina, sound waves hitting your eardrum, the data is often noisy, ambiguous. The brain uses it, but mainly to correct or update its ongoing internal prediction or simulation of the world.
So the experience itself comes more from the inside out.
Largely, yes. The sensory data acts more like error signals. It tells the brain, your prediction was slightly off here, adjust it.
So when I see my coffee mug, the mugness I experience isn't just the light waves.
It's your brain's best guess. Its internal model actively predicting mug based on prior knowledge and then using the light waves to confirm and refine that prediction. The experience is the prediction, calibrated by reality. Evolution makes sure these hallucinations are useful for survival most of the time.
That's a really different way of thinking about seeing. Okay, so if the brain is this prediction machine, constantly constructing reality, how does consciousness fit in? Let's look at the big competing theories. First up, global neuronal workspace theory, or GNWT.
Right, GNWT. Think of the brain as having lots of specialized, unconscious processors working in parallel. GNWT suggests that consciousness happens when information from one or more of these processors gets selected, amplified, and then broadcast widely across the brain.
Like putting it up on a central bulletin board.
Exactly. It passes through a kind of bottleneck and becomes globally available. This allows that information to be used flexibly for decision-making, reporting, memory, and guiding behavior. So for GNWT, consciousness is really about access.
And it often implicates specific brain areas, like the prefrontal cortex, as being crucial for this broadcasting.
That's right. It emphasizes the functional role of making information widely available.
Okay, so that's one major player. What's the main competitor?
The main competitor, certainly philosophically ambitious, is integrated information theory, or IIT.
IIT. This one feels different. It starts with experience itself, right? With axioms about what consciousness is like.
Precisely. IIT starts by listing fundamental properties of any conscious experience, like it exists, it's structured, it's specific, it's unified, it's definite. Then it tries to figure out what kind of physical system could have those properties.
And it lands on information.
Integrated information, specifically. IIT proposes that consciousness is integrated information. It's a fundamental property of systems, potentially regardless of whether they're biological or not.
Okay, integrated information. That sounds technical. And there's this measure, phi.
Yes, Virginal, so mathematical measure. Trying to put it simply, Virginal quantifies how much information a system generates as a whole, above and beyond the information generated by its parts independently.
So it measures unity, how much the system hangs together as an irreducible whole.
That's a good way to put it. If a system has high field, it means its parts are highly interdependent and communicate in complex ways. You can't just break it down into separate components without losing something essential. IIT claims that this measurable property, this integrated information, is identical to consciousness. The higher the phenol, the more conscious the system.
So unlike GNWT, which focuses on access and broadcast, IIT focuses on the intrinsic, integrated structure of the system itself.
Exactly. It's a very different starting point and a different proposed mechanism.
One key axiom you mentioned was unity. Our experience feels unified not just in space, but across time, too. How do these theories handle our sense of duration, of flow?
That's a great question and a tricky one. Philosophers and scientists have different models for how we experience time. One is the cinematic model.
Like movie frames, experience is just a rapid sequence of static snapshots.
Sort of, yeah. The idea is that conscious moments are discrete, like individual frames, even if they follow each other very quickly. It's hard to square with the feeling of continuous flow, though, wouldn't you say?
Definitely. It feels smooth, not jerky.
Right. Some interpretations of IIT, focusing on discrete states of information, might lean towards something like this, but it's controversial. Then there's the retentional model.
Retention, like holding on to the immediate past.
Exactly. This view says that each present moment of experience contains a kind of echo or representation of the moments just past. This retention gives us the feeling of duration and succession. Like hearing a melody, you hear the current note, but it's experienced in the context of the notes that just sounded.
Okay, that sounds more intuitive, like a short-term phenomenal buffer. What's the third option?
The third is the extensional model, which is maybe the most radical. It suggests that conscious experiences aren't momentary snapshots at all. They are themselves temporally extended.
The experience itself lasts through time.
Yes. An experience of change isn't a sequence of static states. It's a single, unified experience that has duration built into it. The flow is part of the experience's intrinsic structure. Think of seeing movement. The movement isn't inferred from snapshots. The experience is an experience of movement.
That's a lot to wrap your head around. Cinematic, retentional, extensional, different ways our unified consciousness might handle time.
Definitely. And it connects back to the function question.
Sure.
Why integrate all this information over time? What's consciousness for?
Right, the why question. Evolution doesn't usually build something this complex and energy-hungry for no reason, although some philosophers argue it is useless, right?
Epiphenomenalism.
Yes, the epiphenomenalist view is that consciousness is just a side effect. Like the heat from a light bulb, it's produced, but it doesn't do anything causally. It happens too late to affect behavior.
But that seems counterintuitive too. Surely my feeling of pain causes me to pull my hand away.
That's the common sense view and the predominant evolutionary view. Consciousness must have some adaptive value. And what's the leading idea for that value?
Integration seems key. Its main job is likely to guide complex, flexible, goal-directed behavior. It does this by taking information from many different senses, from memory, from our drives and emotions, and binding it all together into a single, unified model of the world, a coherent scene.
So you can see the threat, hear it, remember past encounters, feel fear, and plan an escape route, all within one integrated workspace.
Exactly. It provides a stable platform for evaluating situations and making non-reflexive decisions, essential for navigating a complex world and achieving long-term goals.
Okay, but here's the paradox that always gets me. If it's so important, why is human consciousness seemingly so slow and limited?
The seriality paradox.
Yes. I mean, the rest of the brain is this massively parallel supercomputer doing countless things at once, incredibly fast, all unconsciously. Then there's conscious awareness plodding along like a single-core processor from the 90s, one thought at a time, maybe two if we really push it.
It's a striking contrast, isn't it? Our conscious experience feels like this narrow bottleneck compared to the vast processing happening beneath the surface. And often, our unconscious processing is faster and better, like when catching a ball or driving a familiar route.
So if it's slow and sometimes inferior, it can't be the main driver, can it? What else could it be doing?
This leads to a really interesting idea called the interface hypothesis.
Interface, like a user interface.
Kind of, yes. The hypothesis suggests that human-type consciousness might have emerged, perhaps even as a byproduct, linked to the massive innovation engine of our neocortex. Our brains are constantly generating novel ideas, possibilities, internal simulations, a sort of chaotic bubbling of creativity.
Okay, so a lot of noise and new patterns.
Exactly. Potentially overwhelming amounts of complex, nonlinear information. The serial nature of consciousness, according to this hypothesis, acts as an interface. Its job is to select, crop, and linearize outputs from this chaotic generator.
So it takes the messy parallel outputs and translates them into a step-by-step plan that our action systems can actually execute.
Precisely. It turns the complex, high-dimensional neural activity into a simplified, sequential format suitable for deliberate action, planning, and crucially, for communication via language. What we experience as consciousness is this bottlenecked serial interface process.
That reframes it completely. It's not slow because it's inefficient. It's slow because its job is to translate parallel chaos into serial order.
That's the core idea of the interface hypothesis. It's a way to make sense of that paradoxical slowness.
Fascinating. Okay, let's shift gears now to the distribution question. If consciousness is this biological, integrative, perhaps interfacing process, who else has it? This isn't just academic, is it? It has huge real-world consequences.
Absolutely massive,
Yeah.
especially in medicine. Think about patients with severe brain injuries, disorders of consciousness. They might be behaviorally unresponsive, can't move, can't speak. How do we know if anyone is home?
And the misdiagnosis rates are pretty scary.
Shockingly high. Some studies estimate between 9% and 40% of patients diagnosed as being in a vegetative state, unconscious, might actually retain some level of awareness. They're locked in.
40%. That's terrifying. So how can we possibly know if behavior isn't an option?
This is where neuroimaging, particularly fMRI, has been revolutionary in specialized centers. It allows us to bypass behavior and look directly at brain activity. This leads to things like the famous tennis task.
Right. Tell us about the tennis test.
Okay, so you put a non-responsive patient in an fMRI scanner, then you ask them, through headphones, to do one of two mental imagery tasks. For example, imagine you're playing a vigorous game of tennis.
Okay.
Or imagine you're walking through all the rooms of your house, starting at the front door.
And you look for different brain activation patterns.
Exactly. Imagining playing tennis reliably activates the supplementary motor area involved in planning and imagining movement. Imagining walking around your house activates spatial navigation areas, like the parahippocampal gyrus.
So if the patient's brain activates the correct area depending on the instruction.
It strongly suggests they understood the command, they willfully chose to follow it, and they engaged in active, conscious mental imagery. It's evidence of covert consciousness, even when they can't squeeze a hand or blink an eye.
That's incredible. It must change everything for those patients and their families.
It really does. It impacts diagnosis, prognosis, treatment decisions, pain management, ethical considerations. It's profound.
Okay, so we can sometimes find consciousness hidden in humans. What about broadening out? The animal kingdom, how far does it go?
Well, for mammals, the sources we reviewed suggest it's pretty much a done deal. Mice, dogs, dolphins, elephants, apes. They share the fundamental brain structures, particularly in the cortex and thalamus, that seem crucial for consciousness in humans.
So basic phenomenal experience is likely widespread among mammals. What about things like self-awareness, the mirror test?
Ah, the mirror test. Great apes, chimps, bonobos, orangutans, gorillas, along with dolphins, elephants, and some birds like magpies, consistently pass it. They recognize the reflection as themselves, not another animal. This is often taken as strong evidence for a level of self-awareness, though the interpretation is always debated.
Okay, mammals seem likely. But what about really different brains, like cephalopods, octopuses, and squid?
Now we're getting to the exciting frontiers. Cephalopods are fascinating. They're invertebrates. Their evolutionary path diverged from ours hundreds of millions of years ago. Their nervous system is radically different, partially decentralized, lots of neurons in their arms.
But they're incredibly smart.
Notoriously clever. They show complex problem-solving, sophisticated camouflage, tool use in some cases, spatial learning, possibly even play behavior. Based on this behavioral complexity, despite the alien neuroanatomy, many researchers now make a strong provisional case for consciousness in cephalopods.
Wow. Intelligent life, maybe conscious life, evolved completely separately? What about even further out? Insects, crabs?
This is perhaps the most rapidly changing area. Arthropods, insects, crustaceans, spiders. Historically, they were often dismissed as simple reflex machines. But recent research is challenging that.
Like the pain studies.
Exactly. Studies on, say, hermit crabs show they seem to remember painful experiences, like getting a shock in a particular shell, and avoid those stimuli later, even trading off pain avoidance against other needs. This suggests something more complex than a simple reflex. It looks like remembered negative affect.
So not just reacting, but having an experience that influences future choices.
That's the implication. And it led to a prominent group of scientists issuing a declaration recently, suggesting the evidence is now strong enough to seriously consider consciousness extending to insects and other arthropods. It fundamentally shifts our perspective and, potentially, our ethical considerations.
It really broadens the scope of who might have an inner life. Okay, so let's try to pull all these threads together. What's the takeaway picture of consciousness?
Well, it's definitely not one simple thing. It's multidimensional. You have levels of consciousness, awake versus sleep, contents, what you're conscious of, the function, integration interface, the form, unified, serial.
And it seems driven by biological complexity, the need to predict and navigate the world, and this principle of information integration.
Yes, it appears to be a biological feature, deeply tied to the complex ways living organisms interact with their environment. Surprisingly inefficient in some ways, that serial bottleneck, but perhaps essential for flexible behavior and dealing with novelty. And we're finding plausible evidence for it much more widely across the tree of life than we used to think.
Which brings us inevitably to the final, maybe unsettling thought: artificial intelligence. If consciousness is about information integration, like IIT suggests with Phi, or functional access, like GNWT suggests, couldn't a sufficiently complex AI become conscious?
Ah, the million-dollar question. This really hits at the heart of the debate and touches on that simulation versus reality point.
What do you mean?
Well, consider if consciousness is deeply fundamentally tied to being alive, to the specific properties of biological wetware. Think about the messy, analog, complex dynamics of neurons, how every single firing potentially changes connection strengths, the role of neuromodulators, the sheer physical embodiment. Can you truly capture that causal power in purely digital code?
You're suggesting a simulation might replicate the structure or the math, but miss the actual stuff that does the causing.
It's a serious possibility raised by some thinkers. You can simulate a black hole on a supercomputer, right? You can solve all the equations, but the simulation won't generate actual gravity. It won't suck you in.
Or simulating a hurricane won't make my office wet.
Exactly. The simulation describes the thing, but it doesn't necessarily possess the causal powers of the thing itself. So, if consciousness arises from the specific causal powers of biological matter organized in a certain way, then merely simulating that organization in silicon might not be enough to generate genuine experience. Simulating the math of phi might not be phi.
So AI consciousness might be impossible, or at least not achievable, just by making computers more complex in the ways we're doing now.
It raises that possibility. And the ethical stakes are immense.
Yes.
If we could create truly conscious AI, we wouldn't just be creating thinking machines. We'd potentially be creating machines that could suffer. And how would we even know? It's a profound challenge as AI gets more sophisticated. Definitely something to keep thinking about.